in mechanics, suppose this is the ground, and we got an object as x1 moves from here to here. This is x1 and here's x2, and a force applying on it, a constant force F applying on it during its travel. Okay, and now we define the work, the force done on the object from here to here as W work equals to the force times the distance, x2 minus x1. Okay, but how about if the force be not constant and be variable? Okay, in that case we divide this length into infinitesimal parts. For instance, like this, which length is dx, is an infinitesimal. Okay, and here we say that since, remember the area example under the curve, A and B, and the infinitesimal element. Let me draw it here again. Here the values of y, this is y for this point on the axis, x-axis, and this is y, this is from here to here, is y for this point, and this is the x. Okay, and what is y here? I said it before, it is if you took, this is y, the value of y for this point is y plus dy. Let me, from here to here, which is the value of y for this point, is y plus dy, which means that the variation of the values of y over this infinitesimal length at maximum are dy, or is dy. This is the maximum variation of y, which is for these two endpoints. Okay, at maximum they differ as dy. Okay, so it is all, we say that the y over it is almost constant. Okay, now here for this work for the variable force, we say the same thing, and we assume that the variation of the force over this infinitesimal length is almost constant. So the work over it, the work done over it would be F times dx. the distance of this. Then the whole work, and the work got some property that if an object, the force applying on an object from here to here, and the work done on it equals to the work done on it from here to here, plus the work done from here to here, plus the work done from here to here. Okay, so the whole work would be the sum of the works done on each of the infinitesimal lengths, or over each of the infinitesimal lengths. So that would be the integral of this from x1 to x2. And one point here is that it is not a derivation, like the pressure or the area thing. It is more like a definition, because the work should be or could be equal to that if the derivative of work with respect to x be equal to f. So this would be an anti-derivative of f, and would be this. But we have no idea at first about the work a variable force done on an object. Okay, so at first we don't know it. We don't have this assumption.